units and measurement. Okay, now before at the beginning of mankind, okay, the measurement was almost not there. Then suddenly people think that okay, people are cheating on me, so we have to have some level of consistency. So if I am giving you 10 apples and you are giving me say only one orange bag, that means that kind of a cheating. Okay, so apples and oranges, maybe they are not similar in cost, but if I am giving you 10 apples, I am expecting 10 oranges back from you. So that's how the measurement started into existence, and people started measuring, okay, how much amount I am giving you, and in return how much amount I am getting. Okay, so in the past, you know that we had a barter system where exchange method was most popular. Then slowly monetary system came into existence, and then started doing business in terms of weight, right, or mass rather. Okay, and slowly the measurement came into picture. Okay, so measurement is a fundamental process in science to quantify physical quantities. Okay, so to measure physical quantities or quantify means how much is this. Okay, if I say that how long is 1 kilometer is, so that is a quantification. Okay, we can exactly measure what is the 1 kilometer length, or what is the 1 kilogram of mass, or how much time is exactly 60 seconds. That can be measured. So to quantify some physical quantities. Okay, what is physical quantity will come to exist, we'll come to that as well. So measure, that is called measurement. Okay, so measurement is the process of measuring. Next, physical quantity. Any quantity that can be measured and described by a number and a unit is called physical quantity. So physical quantity is something which can be measured and described by a unit. Okay, a value and an unit, then it is called a physical quantity. For example, mass, length, time, they are physical quantities. But the quantities which are not physical quantities, suppose you say that I studied for hours but I did not get enough marks, so that hurts me a lot. Okay, that can be some other context as well, but that hurts me a lot. How much is it hurting you? Can you measure that exact hurt that being put into your heart? Okay, that you cannot do that, right? So that is like a imaginary quantity, that is like a feeling. Okay, that you cannot measure. Okay, or if I say that if that was the case, I would have been very rich. So these things which are perspective, which are not actually be measurable, is called are not physical quantities. Okay, they are imaginary quantities. Physical quantities which physically exist, you can measure them, you can explain them using a value and an unit, then they are called physical quantities. Okay, when we are measuring any physical quantity, we are comparing it with certain basic arbitrarily chosen international accepted reference standard called unit. So what is this unit? Unit is basically something which is arbitrarily chosen. Arbitrarily means you cannot put a proper scientific logic to everything, that why this much length is 1 meter, or why this much weight is 1 kilogram. Okay, that was chosen, that was being done for centuries, even generation before us using that unit, and we are also using that unit. Most of the units are arbitrarily chosen, not all of them. Okay, some of them are there are some scientific logic behind them as well. So, but most cases some common units that we use in our day-to-day life are arbitrarily chosen, because that historically people used to do that. Okay, and it was internationally accepted. It cannot be arbitrarily chosen anything that you might think. Okay, suppose you want to define an unit of your own name. Okay, so suppose your name is say X, and you want to define, okay, this much amount should be X from tomorrow, and everyone should negotiate using this value X. but that is not going to happen, because if you want to sell or buy something in that unit X, other people are people outside your domain, they will not accept that unit. They will say, I only exchange in kilograms, okay, I only exchange in US dollars, okay. Even if you are someone from India, I will not buy anything from you using Indian rupee. I only accept US dollar from you, okay. So that's how international trades happen, right? So we have a fixed currency, we have fixed amount, and based on that we do the trading. So basically it all came, the units, necessity of units, measurement, etc. came from the trading practices, okay. Because trading is not something that is happening today, it is happening for centuries, for thousands and thousands of years, okay. So because of this trading happens, we had to devise a way to trade with the people which are not part of that locality, which is those who are coming from outside, but they are interested. For example, Indian spices, they are famous for throughout the globe, okay, and spice trading is one of the most common trading that happened in India in the past, right? So and many people came into India because of those spices, and so to trade them we had to have some standard units, okay. This much amount you pay, or this much gold you pay, and you can take this much amount of spice from us, okay. That's how the trading used to happen, okay. The result of measurement of a physical quantity is expressed by a number accompanied by a unit. So whenever we say 1 kilogram, 1 is the number, kilogram is the unit, okay. So if I say 20 kilometers, 20 is the number, kilometers is the unit, okay. So basically it has to be two things. You have to, whenever you are defining an unit, it has to be first of all, it has to have a fixed value, and secondly it has to be internationally accepted, okay. So for example, 1 kilogram, the mass of 1 kilogram is there in a museum in Paris, okay. If you ever visit there, you will find that there is a block of mass which is called 1 kilogram, which is kept in a perfect condition of 0 degree Celsius. I think 0 degree or 4 degree Celsius, I am not sure, but the temperature is fixed, okay, and conditions are fixed, the atmospheric pressure is fixed, so that the mass of 1 kilogram is standard, okay. Similarly, the distance between two lines is considered 1 meter, which is also there in the museum, okay. The temperature, the condition has to be fixed, the material has to be fixed, okay. So and if you measure the distance between those two lines, you can get exact 1 meter length, okay. So those are already fixed. Next, so there are a few quantities whose units are fixed, okay. What are all those quantities? These quantities are considered to be primary quantities: length, time, mass, electric current, thermodynamic temperature, normal temperature, whatever temperature that we say, also called thermodynamic temperature, okay. Luminous intensity, something that you may not be super familiar, but it is also a fundamental quantity. And amount of substances. Amount of substances you have used in chemistry, right? These 7 quantities are considered to be fundamental quantities, okay. And they also are represented using certain symbols. Those symbols are called dimensions, okay. The dimensions of a physical quantities refer to the nature of the quantity in terms of the fundamental physical dimensions, okay. So fundamental quantities are these 7, and their respective dimensions are given in this chart, okay. So length is represented by L, third bracket, time is capital T, mass is capital M, electric current is generally A, okay. For 99% of your life you will use A only. Temperature is K or capital theta. Capital theta is very less used. In old generation it was used capital theta, now it is used as capital K only. Luminous intensity is CD. CD comes from the unit candela, okay. Candela is the unit of luminous intensity. From there it is not cadmium, by the way, it is candela, okay. And amount of substance is mole. And whenever you express a dimension, it is always represented using a third bracket, okay. Third bracket is common for all the dimensions, Clear? So here is a small table to remember. So here mass, current, okay, mass is kilogram, just for a representation. Okay. The unit, SI units, length, SI unit is meter, time is second, mass is kilograms, electric current is ampere, thermodynamic temperature is Kelvin, okay, luminous intensity I already mentioned, candela, and amount of substance is mole. So these are also the SI units. Okay, so for some of the quantities, as you can see, their units are exactly same as the symbol for their dimensions. Okay, except the first three. First three was more fundamental. It is there from the beginning. Later on, people realized, okay, these three are not the only fundamental quantities. There are few more quantities which are fundamental, and that's why they have added this another 4 quantities into the list. The total 7 quantities are considered to be fundamental quantities. Fundamental quantities means they are not dependent on anything. Okay, so current is not dependent on anything. Current is considered independent. These quantities are independent of each other and anything else. Okay, so these are considered to be fundamental quantities. Now there are 2 more units which are called supplementary units. Number 1 is angle. Okay, angle by dimension is a dimensionless quantity. Remember that even though it's an unit, by the method of dimension, it's a dimensionless quantity. So even though you can measure it, even though it has a value, even though it has an unit, fundamentally it is a dimensionless quantity. So if they ask you name a quantity which is a dimensionless quantity, but it has a unit. Okay, so there are 2 quantities actually, this one and another one. So this is a dimensionless quantity, but still it has a unit, and the unit is radian or degree. Okay, radians or degree, which both of them are dimensionless quantity, and they are also has a unit. So, and one more important thing. So when you measure an angle, okay, generally if there is a curved line, okay, suppose this is a curved line, say curved line, length of the curved line is given by S. Okay, length of the curved line is given by S, just a second, and this distance is say given by R. Okay, so this distance is R and this distance is S. Then if this angle is theta, then S equals to R into theta. Okay, S equals to R into theta. Okay, so this is the relationship between the arc length, the radius of the circle, and the angle it makes. Okay, so if it's a curve, obviously it will have a center, okay, of curvature or radius of curvature basically. So if you join them back towards its center, okay, this is the radius of curvature and this is the arc length S. So you can calculate the exact arc length from this formula. S equals to R theta. Now remember, here theta is expressed in radian. Theta is expressed in radians. Okay, so this is the formula. So you can calculate theta equals to S by R. So if you know the arc length, if you know the radius of curvature, you can the angle theta. Now if you see that it is basically a ratio of similar quantities. Arc length dimension is L, radius dimension is L, so it's a dimensionless quantity, but still it has a unit which is called radian. Okay, remember that, and obviously maximum value radian made by a circle. If you are given a circle, okay, and if they ask you what is the angle that it makes, so this angle is pi by 2. Okay, the total angle is pi plus pi, that is 2 pi. Total angle subtended inside a circle is 2 pi. Okay, so that's why the perimeter of a circle is 2 pi r. Okay, so 2 pi r, you can calculate 2 pi r is the perimeter. Same formula, actually everything comes from this formula only. Next is another dimensionless quantity which is called solid angle. Solid angle is basically, angle is a 2-dimensional thing, solid angle is a 3-dimensional angle. Okay, when you consider an angle in 3 dimension, it is called a solid angle, and in this case the surface is a part of a sphere. Okay, it is not a part of a circle anymore, it's a part of a sphere. If it is a part of a sphere, then if you join them back at the center of the sphere, okay, the angle it subtends is called solid angle. Okay. The angle it subtends is called solid angle, and it is denoted by capital omega. Capital omega, same as the symbol of resistance. Okay, so this is the symbol for solid angle. Solid angle is like a conical shape. Okay, it's like a conical shape. It's a three-dimensional angle. Its unit is steradian. Its unit is steradian. If you know the area, if you know the radius of the sphere on which it is the surface is located, then it is given by area divided by r square. Area divided by r square. It is also a dimensionless quantity. So both plane angle and solid angle are dimensionless quantity. Okay, both are dimensionless quantity. The angle subtended by a sphere at its center is 4 pi. So angle subtended by a circle is 2 pi, angle subtended by a sphere is 4 pi. So if you consider a sphere, okay, if you consider a sphere and if you go into its center, the total solid angle that it subtends is 4 pi and unit will be steradian. Okay, now you may have used some formulas like sin theta nearly equals to theta or tan theta nearly equals to theta for small value of theta, for small value of theta, okay, or cos theta equals to 1. These all formulas are valid when theta is expressed in radians. Remember that. These are all valid when theta is expressed in radians. These are all not valid for theta equals to degrees. They are only valid when theta is expressed in radians, not in degrees. Clear? Now let's move on to significant figures. So digits in a measurement that are reliable plus the first uncertain digit is called significant figure. Okay, significant digits are those digits obtained by a measurement and not by a calculation. Remember that significant figures are always comes from a measuring device, or when you are using a physical value, you are measuring it, then it is called significant figures. Okay, these are not part of a calculation. Okay, even though we use significant figure rules while calculating something, but the actual significant figure comes when you are using some measuring tape or some measuring device to get the exact value, then it is called significant figures. Now what is the meaning of this reliable plus first uncertain digit? What is the meaning of that? So suppose you have a measuring device. Suppose you are measuring a mass using some balance. Okay, we all have seen this kind of balance, right? Nowadays we use digital balance, right? Now suppose we are using some old school balance mechanism. We have some object over here and some mass, known mass over here. Okay, suppose it is showing, the scale is showing almost at the center, but not exactly at the center. Okay, slightly towards this, slightly heavier on the side of the object. Okay, that means suppose we have a 2 kg on this side and we have some object over here. Now when it is almost exactly at 0, when the scale is exactly at 0, then we can say that mass of this object is also 2 kg. Right, so 2 kg on my left hand side, that means 2 kg on our right hand side. But in case, suppose we instead of having exactly 2 kg, suppose the scale is now tilted on this side. Scale is slightly tilted. That's how the people used to give you, right? So it is heavier on this side, you can take little extra from me, right? So now that, what does that mean? That the mass is not exactly 2 kg. 2 kg is guaranteed. 2 kg is guaranteed. That is the reliable. So 2 kg is the reliable mass. Okay, but it's slightly more than 2 kg. That means what we can say, maybe it is 2.1 kg. So this value is reliable. This one is reliable. And this one is, we are assuming, or we are getting, okay, this is slightly more than, slightly more, okay, slightly more means this will be uncertain. This is the uncertain value. This can be 1, this can be 2, this can be 3, but because it's slightly more, we will take this as 0.1. Okay, similarly, when you measure using a scale during examination, okay, when you measure using a scale, okay, especially during lab experiments, what you do, suppose this is 0, okay, and this is say 1, in between we have say 0.5, okay, and we have 1, 2, 3, 4, 0.6, 7, 8, 9. Okay, suppose this is the scale. While measuring, you found a result which is somewhere between 0.8 and 0.9. Somewhere between 0.8 and 0.9. Now, sometimes it was said that it is better to take the smallest value. Smallest value is certain. Okay, so 0.8 is certain. Suppose you found the length is here. So 0.8 is certain. So it will be 0.8. But you say that, okay, this value is very close to the midpoint of 0.8 and 0.9. So we can write this as 0.85. So this value is uncertain. Right? This value is uncertain because this is not exactly, we are not sure whether it is 0.5 or 0.6 or 0.4, but this value is something which you can say this is very close to this value. So this is the uncertain value. This one is the reliable value. Okay, this one we can say directly exactly it has to be greater than 0.8, right? So 0.8 is reliable. Anything slightly more than that will be uncertain. That is, according to our guess, according to our observation, we are getting this value. Now remember, all the values that we are saying over here are all coming out of experimental measurement, not from any calculation. For example, what is the meaning of that? Suppose you measured the length to be 0.85 say meter, okay, and you measured the breadth to be 0.5 meter. Now when you calculate area, area will be L into B. So this is a measured value. Okay, this is a calculated value. Okay, these two are measured. Okay, this is a calculated. So there, so when you calculate the area, the value of area will include significant figures obviously, but when we are saying that significant figure, that actually comes from the fact of actual measurement, not from a calculation. So after calculating the area, we have to consider the significant figures, but the result itself, we cannot say that it is a significant figure. Okay, that is not a significant figure of the area. Okay, that is the actual value of the area, considering significant figures. But the final result is not in significant figures. It is in it will be called as area itself. It will be not called area in significant figures. No. Okay. Now a few common rules that you need to remember while considering significant figures. Okay. Non-zero digits. All non-zero digits are significant. All non-zero digits are significant. For example, 123.45 has 5 significant figures. This is very common type of question where they will give you a number and they will ask you what is the significant figure. So if you know 123.45, so has 5 significant figures. Leading zeros. Leading zeros means zeros which are coming first. Okay, zeros that precede all non-zero digits are not significant. Any zeros which are coming before non-zero digits are not significant. For example, 0.0025 has only 2 significant figures, that is these non-zero digits. Okay, these zeros are not significant. Captive or sandwiched zeros, okay, or burgered zeros. Okay, so between burger patty you have a zero in between, so those zeros are significant. Okay, zeros between two non-zero digits are always significant. For example, 1002 has 4 significant figures, even though there are 2 zeros, which is basically sandwiched between 1 and 2, so those 2 zeros are significant. Now trailing zeros are in a decimal number. So trailing zeros in a number with a decimal point are significant. So if I say that 10.0 0 0, all zeros are significant. All zeros are significant. So here 50.00 has 4 significant figures. Remember that? So 10.00 means there are 4 significant figures. This is very tricky. This is very tricky, okay? So whenever there is a decimal point, okay, all zeros are significant. Next, trailing zeros in a whole number. Trailing zeros in a whole number with a decimal point are significant. So here also trailing zeros, as you see that here 100.0 has 4 significant figures. Trailing zeros in a whole number without a decimal point. So trailing zeros in a whole number without a decimal point are not significant. So 100.0 has 4 significant figures, but if I just write 100 or if I write 1500, these two zeros are not significant. Okay, it is only has 2 significant figures. Okay, so 1500 has only 2 significant figures. Very, very important. If you add a decimal, okay, so if I say that 1500 point, just a decimal, then all these zeros are significant. Okay, these are significant. But if I write 1500 only, then these zeros are not significant. Okay, very, very crucial to remember. If there is a decimal point means the device that we are using to measure the length or mass or whatever quantity that we are measuring is capable of measuring quantities after the decimal as well, but this is a very specific value. This is the exact value, so that means these zeros are significant. If zeros are not, if there is no decimal, that means it's just a value. Okay, we do not know exact capability of the device measuring this value. That means only 2 significant figures. That is the exact meaning of it. Okay, you don't need to remember the meaning, but you have to remember that if there is a decimal point, zeros are significant. If there are no decimal points, zeros are not significant. Very, very important point to remember. Exact numbers, for example, 1 dozen. Okay, exact numbers are infinitely significant. Okay, so if I say that 1 dozen, 2 dozen, okay, exactly, say exactly 15 or exactly 10, they are infinitely significant. Why so? Because if I say that 12 dozen, 1 dozen exactly means 12. That means after a decimal, if you put 1, how many zeros does not matter, no matter how many zeros are there, okay, it will still be exactly 12. It will not be 12.001. Okay, so that means because it's a exact number, that means it can go, if you can put a decimal and you can write infinite number of zeros after that, that's why an exact number is infinitely significant. An exact number is infinitely significant. Next, scientific notation. Scientific notation is also important. All digits in the scientific notation, number written in scientific notation are significant. So for example, so if you write this number, these numbers, all the numbers are significant. 10 to the power values are not significant. Okay, 10 to the power values are not significant. These 3 or 4 are not significant. Okay, only this 2.30 are significant. Choice of unit, a choice of unit or changing the unit does not change the number of significant figure. For example, 2.03 centimeter has 4 significant figures. It won't change if you switch into meter. Okay, so if you change the unit, the significant value does not change. Okay, significant digits does not change. So whatever significant digits was there in centimeter, no matter if you convert it into meter or kilometer or decimeter, the number of significant digits will not change. Number of significant figure will remain unchanged. So it is independent of units. Next, rules for calculation. This is also very, very important. Addition and subtraction. So the result should have the same number of decimal places as the number with the least number of decimal places. So when you are adding two numbers, okay, you need to consider significant figures also. Okay, so for example, 12.11 plus 0.2. 12.11 plus 0.2, if you see that here we have only one decimal point. Okay, here we have how many? 2 decimal points. So out of these two numbers, who is smallest? Smallest is 1. So the answer will also have only 1 decimal point. So basically what you have to do, how to do that? Suppose we have 12.34 plus 0.5. Suppose we are doing this addition. So first thing you have to approximate this number into the 1 decimal point, that is 12.3. okay, and then add this number, that is 0.5, then you get 12.8. okay, this is one method, or you can simply add that, okay, 0.84, and then you say that there is only 1 decimal point, so we can drop this 4. okay, we have to consider and ignore this 4, right? So 0.5, so 12.84, so you can drop this and answer will be 12.8. okay, we will see that further in rounding off rule. In some cases you have to round off and the answer slide can be changed based on the rounding off. So after adding that, you have to round off to the nearest smallest decimal number. okay, in case of multiplication, again the result should have the same number of significant figures as the number with the least number of significant figures. So for addition, decimal point is important, not the total significant figures. In multiplication, total significant figure is important. Both cases we take the least. okay, so here we take the least with the decimal number. In case of multiplication or division, we take the least significant figure. okay, so for example, 4.56 into 1.24. So this one has how many significant figures? 3. This one has how many significant figures? 2. So our answer should also have 2 significant figures only. So this is a rule for multiplication. Normally, obviously, we do not follow this exact rule, but in exam, if they say that this is multiplied by this, what is the answer according to the significant figure rule? okay, you have to multiply them and you have to find the least. So minimum 2 digits are there, so you have to identify a number with 2 significant figures. okay, that's how you can even guess the answer. okay, because they will give you same answer with different significant figures. You don't, if you see this kind of question in the exam, the question is not about the exact multiplication, but the answer which denotes the correct significant figure. So they will suppose they will give you 4.56 into 1.4. Suppose they will give you answer 6.32, 356 or 6.4, or they will give 6. okay, so which one is correct? So we know that here we have 2 decimal number over here, so 2 significant figure over here. So our answer should be 2 significant figures. So only this one is 2 significant figures. This one will be the answer. So you don't need to do the multiplication to check whether it will be 6.4 or 6.356, but you have to calculate. Okay, this is the significant figures. That means from the significant figure, answer will be 2 significant figure only. okay. If the digits to be dropped, now rounding off. Now how to round off a number? Suppose we have a number, say xx comma yz. okay, suppose this is a number. okay, x okay, let me change the number, sorry. Say xy comma z q. Suppose this is there is a number like this. Now if you want to drop this number, you want to round off this digit into 3 significant figure. okay, suppose round off this to 3 sig fig. So how to do that? So you can simply write xy dot z. okay, but that may not be correct, that may be correct as well. Now based on this digit which you are dropping, that is you are removing, you are not writing in this equation, okay, whether this number is greater than 5 or less than 5, you can have 3-4 different rules. okay, so what are those? If the number is less than 5, you can simply drop that number. okay, you can simply drop that number. So if q is less than 5, then the answer will be xy comma z, xy point z. you can simply drop. So for example, here we had 12.43 and we are rounding off into 3 significant figures. So that means we are dropping this 3. This 3 is less than 5. So simply answer will be 12.4. If the number is greater than 5, if the number is greater than 5, then what you have to do? If the number is greater than 5, then your answer will be xy point z plus 1, okay, if q is greater than 5. So for example, if the number is 12.46, this 6 is greater than 5. So it can be 6, it can be 7, it can be 8, it can be 9, okay, does not matter. As long as the number is greater than 5, when you are rounding it off, it will be 12.5. So you have to increase this by 1. You have to increase the number by 1. Okay, now what would be the case if the number is exactly 5? If the number is exactly 5, then you have to consider 2 more rules. This is tricky. These 2 are easy. Obviously, we are using it in our day-to-day life, almost every calculation. But if it is exactly equals to 5, then the calculation can be tricky. Okay? If the number that we are dropping, the number before that, if the number is odd, okay, if the preceding digit is odd, then we increase it by 1. Okay, so if the number is say 12.35, this is an odd number. Okay, we are dropping this 5. Okay, it is neither greater than 5 nor less than 5. It is exactly equals to 5. And the number before this is odd number. We increase it by 1. Our answer will be 12.4. But when you are dropping a number, if that number preceding it is even number, for example, 12.45, 4 is an even number. Okay, so in that case, after the rounding off, it will be 12.4. We do not do anything. So if the last number is 5, exactly equals to 5, the number that we are dropping, if that number is 5, remember that your final answer should be an even number. Okay, your final answer should be an even number. That's how you can remember. Okay, if I am dropping a 5, it should be an even number. If number is after dropping, if the number is already even, we don't do anything. If the number after dropping is odd, then we increase it by 1. So it will be 12.4. Okay, remember that. Your answer is always even number. So this is also 12.4, this is also 12.4. Even though the number that we started with are different. Okay, this is very, very tricky. Other than that, all the rules are very simple. Let's move on. Now, uncertainty based question. This example is exactly there in your NCERT. So what is the meaning of uncertainty? Uncertainty is something which the digit that we are measuring, the last digit that is not certain. Okay, how much error is there? That is a measure of error. Okay, uncertainty is a kind of measurement of error. Okay, so uncertainty should be converted into percentage first and then added. Okay, so for example, how the uncertainty is written. So for example, if you see that here length is measured of certain quantity, which is measured as 0.3, it is a certain value, plus or minus 0.003 centimeters. So this is called uncertainty. Okay, exact definition, exact understanding of uncertainty is not super required because it is not part of the syllabus, but these kind of calculations are there in your book, and this value is called uncertainty. Uncertainty means like Heisenberg's uncertainty principle. Similarly, the value is not exactly fixed. You cannot exactly say whether it is a 0.3 or 0.303 or 0.2907. Okay, 0.2907. It is basically varying. It is varying between those two digits, 0.2997 or 0.303. So it is actually between these two values. Exact value, obviously 0.3 is known, but whether it is a plus or minus, exactly not known. So this is called uncertainty. So between these two ranges, the value changes. Okay, so this is called uncertainty in the measurement. Okay, based on different cases, uncertainty can appear. Okay. So length is given by this value and breadth is given by this value. Okay, 6 plus or minus 0.03 centimeter. Now if they ask you what is the area, how to calculate the area, obviously you can normally what we do, we multiply length and breadth to calculate the area, that is 1.8, but in this case you cannot do that. So how to do that, how to achieve that? First of all, you have to convert this number into percentage using this value. How to convert it into percentage? So here uncertainty or delta L, uncertainty is represented by delta L. So delta L is obviously 0.003 and actual length was given by 0.3. Okay, so you divide it and then you multiply with 100. This is the percentage error. This is called percentage error. So decimal is gone. So you get 0.03 multiplied by 100, you get 3/3%, that is 1%. So error is 1% or uncertainty is 1%. Okay, in terms of breadth also you have to do the same thing. So delta B by B. So delta B is 0.03 divided by 6 into 100%, that is 3/6%, that is 0.5%. Okay, so as you can see, the uncertainty in length is 1%, uncertainty in breadth is 1.5%. Now when you calculate the area using the formula, okay, these two will be usually exactly how you calculate the area. Okay, so length into breadth, so 0.3 into 6, that is 1.8. Done. When you calculate the uncertainties, here you have to add them. Okay, here you have to simply add these two quantities, so it will be plus and minus 1.5%. Now 1.5% of what? 1.5% of this. Okay, now from percentage you have to go back to the number. How to do that? So the L into B is 0.3 into 6, that is 1.8, and from there you can calculate the percentage. So delta area by area equals to 1.5%. I don't know why it is not working. Just a second. So this will be 1.5%. It will be 1.5%. Now you have to cross multiply to calculate delta A. Percentage means 1.5 by 100. Obviously, when you convert into percentage, you multiply by 100. When you go back from percentage to fraction, you divide by 100. So delta A is actually area into 1.5 by 100. Okay, that is 1.8 into 1.5 by 100, which will come out to be 0.03. Okay, so it will be 0.03 centimeter square. Okay, so this is how you calculate the uncertainty. Remember that generally if it is given in terms of percentage, you can simply add it to find the uncertainty. Okay, this is a slightly longer complicated problem given in your textbook, but remember that how to calculate or how to add the uncertainties, it always has to be converted into percentage and then you can add it. Okay, error assessment is not there in your syllabus. Now one important question: if P, Q and R are physical quantities having different dimensions, so their units and dimensions are different, okay, which of the following can never be a meaningful quantity? Suppose we have, say, a quantity A which is measured using kilograms. We have another quantity, say B, which is measured using, say, meters, and another quantity, say C, which is measured using seconds. For example, I am taking three fundamental quantities. Now if I say what is the quantity if I add A plus B, so if you see that here A is in kilograms, B is in meters. Can we add them? Can we add kilogram plus meter? So this does not make any sense. This quantity does not exist. So any two quantities having different dimensions, they will not exist in nature. Okay, so I have taken three fundamental quantities to explain it better. So remember that when you are considering quantities, okay, they can be fundamental, they can be derived as well. Derived means obviously any units which are not fundamental are called derived, which is basically sum or multiplication of, which are multiplication or division of fundamental quantities are called derived quantities. So two different quantities cannot be added. Two different quantities cannot be added. You can add only if their dimensions are same. So if I say that x plus y equals to z, then dimension of x will be automatically be dimension of y and automatically be dimension of z. Okay, so these three, if I say that x plus y is equal to z, then x dimension, y dimension and z dimension, they will also be equal. Okay, we can however multiply these dimensions. So we can however say AB by C, kg meter per second, okay, unit of momentum. So this is a dimension for momentum. So multiplication, division, etc. is possible. When you are considering two dimensions, their multiplications and division is possible, but their addition, direct addition is not possible. So if you see here directly which quantity is not possible, if you see that here P minus Q is there. P minus Q, P and Q both are of different dimension, so you cannot subtract two different quantities. Okay, you cannot subtract two different quantities, that is not mathematically possible. So kilometer minus meter, kilometer minus second is not possible. Kilometer minus meter is possible. Okay, you can convert kilometer into meters and you can convert it, but dimensions are different, means P and Q have different dimensions. So this operation, this negative operation is not possible. So this is not possible. So this quantity is dimensionally not possible. Now this quantity is obviously possible, as I mentioned. Now you might say, sir, then how can this quantity be possible or this quantity be possible? They are also negative sign, but here if you see that they are not directly simply they are not subtracting from each other. Okay, if this quantity say PQ minus Q square was there, then this is not possible. Why? Because if you take Q common, you get P minus Q. So this quantity is not possible. Simple subtraction between two fundamentally different quantities are not possible. But when you multiply a third quantity which is completely different from there, P and R may have same dimension as Q square. Okay, P into R may have same dimension as Q square, okay, because these two are completely different quantity. So these two quantity, if you multiply them, they can have a dimension equal to Q square, right? For example, G into H, okay, gravitational acceleration into height, that can give you a dimension of velocity. Okay, so GH equals to Q square can be still possible. Okay, so that is a well accepted quantity. Similarly here also, if you see P into Q minus R, P into Q can give you a quantity which is dimensionally P and Q can have a dimension same as R, which are different in dimensions. Okay, so these quantities can have different dimensions, right? So these two are possible, but this one is not possible because of straightforward difference. Okay, and this is a KCET 2019 question. These kind of questions are common, very fundamental basic question. Okay, so be prepared for those kind of questions. Obviously we will practice more PYQs in our PYQ session. Now let's continue. Now let us complete the remaining chapters quickly. Motion in a straight line, just a second. So first obviously is velocity, speed and acceleration. So these are the three quantities that you must know. So the instantaneous velocity is given by dx by dt. Obviously how fast an object is moving with respect to time is velocity. Okay, time rate of change of displacement is also called velocity. But when it comes to instantaneous velocity, it depends on how fast the object is moving over a given period of time, that is called instantaneous velocity, and it is given by dx by dt. Now if you are given a displacement time graph, okay, x versus time graph. Okay, if this is the graph, then dx dt basically represents, let me change the color. So basically dx by dt gives you the slope of the graph. Okay, so this is dx, this is dt, and dx by dt basically gives you the slope of the graph. So at a certain point of time, if you know the slope, you know the instantaneous velocity. Slope of the displacement time graph at any given instant gives you the instantaneous velocity. Instantaneous acceleration is rate of change of velocity. So basically, in other words, you can say that this is nothing but, this is equals to double derivative of displacement. Okay, so d2x dt square. So if you, similar way, if your velocity time graph is given, slope of a velocity time graph gives you acceleration, and average velocity is very common, total distance traveled by total time taken, right? Now let's move on. Few graphs that you have to remember, because the graphs are very common, and many times graphs are asked in the exam. So xt graph, xt is displacement time graph. The slope of displacement time graphs gives the instantaneous velocity. Velocity time graph, area under velocity time graph represents the total distance traveled, and slope of velocity time graph gives you the acceleration. So as I mentioned, okay, now area under the xt graph does not gives you anything. Vt graph, area under the graph means what is, suppose this is velocity, this is time, so this represents area under the graph. Okay, we have applied that in your P1. If you remember, different expressions for velocity, then total distance traveled, we calculated using this graph. Okay, and one aspect of the derivation was that area under the graph gives you the displacement, right? Or total distance traveled. Now in case of speed time graph, it is total distance traveled. In case of velocity time graph, it is the displacement. Okay, slope of velocity time graph gives the acceleration. Now acceleration time graph, area under acceleration time graph represents the change in velocity. This is very important. So change in velocity is given by area under acceleration time graph. Now there are three different graphs for position time graph. Okay, first of all, when acceleration is positive, acceleration is negative, acceleration equals to 0. So these are the three graphs which represents three different cases. These cases are very, very important. So for positive acceleration, when the acceleration is increasing with time, the xt graph will be increasing as well. Okay, it can be, it not necessarily like that, it can be like that as well. Okay, the graph should be curved and it should increase with time. Okay, it should increase with time so that you can calculate the exact slope. If you can calculate the slope, you can calculate the velocity and correspondingly acceleration as well. Negative acceleration, the displacement decreases with time. Okay, and if it is a straight line, graph, acceleration is 0. And if it is a constant velocity, if the object is at rest, then this will be the graph straight. Okay, it will be parallel to time axis. If the graph is parallel to time axis, velocity equals to 0. Velocity equals to 0. Constant velocity, it will be a straight line graph. Okay, now when the object, if you drop an object at some height, okay, and if only force due to gravity is acting on the object, then it is said that object is at free falling state. Okay, or it is a free fall. Free fall means object is falling under the influence of gravity. That motion is called free fall. And in case of free fall, if you plot the graph of velocity versus time, then the graph will be like this. Now why this is a negative graph, why the line is negative? Okay, because as the velocity object is falling downward, okay, its velocity in the downward direction increases. Velocity in the downward direction increases. So downward direction means the distance from the surface of the earth is decreasing. That's why it considered as negative direction. Okay, anything which is falling towards earth is negative, anything which is going upward is considered positive. Similarly, the distance traveled with respect to time is actually like this. Okay, and it is slowly starting from some height and going towards 0. Okay, ignore this. So it will be having some positive value and slowly it will going towards 0. This might be true when the object is going into the surface of the earth. Okay, so 0 surface is the earth surface, and if the object is going into the surface, inside the surface, suppose you dropped some stone inside say a mine. Okay, there is an open mine, you drop an object, or a well. Okay, well, you have seen well, okay, water wells. So if you drop a stone inside a well, this graph will be like this. Okay, the distance will be negative inside the surface of the earth, right? So this is the general graph for displacement. This is general graph for velocity for free fall. Okay, now equation of motion, very important. There are few equations of motion that you need to remember, obviously very common. We are using all equations of motion in multiple times. So V equals to U plus AT. V is velocity, U is initial velocity, A is acceleration, T is time. S equals to ut plus half at square. This is also very common equation. S is the displacement, u is initial velocity, A is acceleration, T is time. Okay, and v square equals to u square plus 2as. Now all these three equations are interlinked. Okay, interlinked means you can use one equation to go back to any other equation. So basically these three equations are not very independent. You can go from one equation to another very easily. But why do we need three equations? Based on what are the values that is given to you and what are the values that you want to calculate. So based on that you can use any one of the three equation of motion. Out of that, this is considered to be most fundamental. Okay, this equation, and other equations can be proved from this equation, right? Now distance traveled in nth second, this can be sometimes handy if you know. If you don't know, does not worry, you don't need to remember this or memorize this formula. So distance traveled in nth second is nothing but suppose total distance traveled in n minus 1 second and distance traveled in total distance traveled in nth second. This is called distance traveled in exact nth second. Okay, that means suppose you are moving in a car. Okay, you are moving in a car exactly in the 10th second. 10th second means that 1 second between 9 and 2:10, that exactly 1 second how much distance you have traveled. To calculate that, we generally use this formula. Okay, so this is the formula to calculate the distance traveled in nth second. You use these formulas for n and n minus 1 and then find the difference between them. That will give you the exact distance traveled in the nth second. Okay, so this is a shortcut formula. Sometimes it can be handy to save some time. That's it. But mostly this formula came in JEE. In KCET, I think only once if you had used this formula would have been some time saving for you. Otherwise, not super important. As I mentioned, this formula is obviously, these two formulas are obviously important, and based on what values are given to you and what you are trying to calculate, you need to use the exact formula. Let's see one question from 2025. Two stones being fall from rest from the same height with the second stone starting to fall at delta t seconds after the first falls from the rest. Okay, the distance of the separation between the two stones becomes capital H t naught seconds after the first stone starts its motion. Then t naught is equal to, so this is slight printing error, this is t naught. Okay, this is t naught, not to. Okay, so two stones being fall from the rest at the same height. So we have, suppose a tall building. Okay, we drop one stone from the rest. Okay, first stone was allowed to fall. Okay, and after delta t seconds, you allowed the second stone to fall from the same height. Okay, first stone already started to fall, and after delta t seconds you allowed the second stone to fall. Okay, now it says that after some time t naught, okay, after some time t naught, after the first stone starts, so after t naught of the t naught of the first stone, okay, the height that these two stones have achieved, say, is capital H. Okay, now they asked you what is the value of t naught. Okay, so obviously when you drop the first stone, it started from the rest. So what is the total height or total distance traveled by the first stone? Say H1. Total distance traveled by the first stone, H1, is given by half g t naught square. Okay, this is the total distance traveled by the first stone. Now what about the second stone? Second stone covered, say this height is say H1, this height say H2. Second stone actually started to fall after delta t second. Okay, so the same formula will be same, only here it will be t naught minus delta t whole square. Okay, only this will be the difference. Why? Because obviously the second stone started delta t seconds after the first stone. Equation of motion, first equation is obviously very simple because the time t naught is given in terms of first stone. So first stone is total time is t naught. For the second stone, because the second stone starts after delta t seconds, the time will be t naught minus delta t for the second stone. So in the question it is given that H is actually H1 minus H2. H is equals to H1 minus H2. So this value is given in the question, and from there you are supposed to calculate this t naught value. Okay, so now let's start. So H equals to obviously half g will be common. So half g, that is g by 2. It is common, and in bracket we can write t naught square minus t naught minus delta t whole square. Right? Now we have to simplify. So 2h by g equals to t naught square, that is a square minus b square. We can apply that, a plus b. So a plus b is t naught plus t naught minus delta t into t naught minus t naught plus delta t. Right? So obviously t naught cancels, and you can write this as 2 t naught minus delta t into delta t. Okay? Or you can write this as 2h by g into delta t equals to 2 t naught minus delta t. Now obviously t naught is much larger than delta t is very small time. So you can ignore this delta t. With respect to t naught, delta t is very small. So you can ignore this delta t, and you can write 2 t naught equals to 2h by g into delta t, or 2 cancels, and you can say t naught equals to h by g delta t. So correct answer is option D. Okay, h by g delta t. So this is the correct answer. So obviously not super simple, not super difficult as well. So if you know the formula, how to solve it, do step by step method, and at the end just ignore this term, because delta t is obviously, because it's a small distance, it is denoted by delta t. If it is a very large distance, it does not make any sense, the problem does not make any sense. Okay, so obviously delta t you can ignore. Right? So this is the end of the second chapter. Now let's move on to the third chapter, motion in a plane. So first concept that we are going to discuss in the third chapter, which is scalars and vectors. So a scalar quantity is a quantity with magnitude only. Scalar quantity is a quantity which only have magnitude but do not have any proper direction. Okay, it is specified completely by a single number along with the proper unit. The rules for combining scalars are the rules of the ordinary algebra. For example, mass. Okay, 2 kg mass. Mass does not have any direction. If you want to add 2 kg mass with another 2 kg mass, you just need to add them. 2 plus 2 equals to 4. So that is simple addition method. So for any scalar, you just need to know the value and you can simply add them algebraically. Now not always it will be positive. For example, plus 2 coulomb charge and minus 1 coulomb charge, if you add them, you will get 1 coulomb charge only. So sometimes plus and minus is possible. Okay, displacement, for example, distance traveled. Okay, suppose distance traveled is a scalar quantity. If you travel 2 km and then another 2 km, it will be added. 4 km is the total distance traveled, independent of the direction. Similarly, there is one more quantity which depends not only on value but also on direction. That quantity is called vector quantity. So vector quantity is a quantity that has both magnitude and direction and obeys triangle law or equivalently the parallelogram law of addition. So when you are trying to add two quantities and you are not always getting exactly 2 plus 2 equals to 4 is not happening, then you will say this must be a vector quantity. So 2 plus 2 is not always equals to 4. It depends on whether the quantity have a direction or not, and if they have direction, whether they are in the same direction or not. For example, if you travel 2 km in the east and then 2 km in the north, your displacement will be 2 into root 2 km in the east north direction. Okay, so 2 km in the east, okay, and 2 km in the north. Suppose this is how you traveled. Now what is your displacement? Your displacement will be in the northeast direction and it will be 2 root 2 km. It is not 4 km. Okay, so 2 plus 2 is not always 4. So here we are using triangle law of addition. You can use parallelogram law of addition as well. Now before going into that, we have to know something very important, which is called resolution of a vector. Resolution means, what is the meaning of resolution? Not New Year resolution. Resolution means dividing. Okay, dividing. So basically where we have a vector, suppose we have a vector, say A vector. It is completely given like this. We have no idea what is the exact position, and based on the question, based on the situation, we resolve this vector into two perpendicular vectors. How to do that? We consider now these axes that we are going to discuss about resolution. It can be based on the question. It can be any two perpendicular vectors can be considered for this. We are generally we will like to do it in terms of our known coordinate system, x and y axis. So we will take one component along the x direction. Okay, just a second. So these are the two directions that we generally consider. One is, say, this is x, this is y. Okay, so when one vector is given and we choose two perpendicular axes and we take the component of this vector along this axis, then they are called two components of the original vector. So how to take the component? For that we have to draw a perpendicular from here to here. This will give me the x component of the vector. We'll denote it by ax, and we take another perpendicular on the y axis, and this gives me the y coordinate. So this is ay. Okay, so ax and ay are the two components of the vector A. Now if this angle is denoted by theta, it can be any one of the angle. Now I will tell you the secret of that as well. So if you know the angle, one angle you know, then you can find the components as well. So the adjacent component means the component which is next to the angle. So here this theta is next to the x component. So ax will be the original vector into cos theta. Here a is the magnitude of the vector, obviously. Magnitude means only the length. So whenever we say that this is a vector a, okay, that means this length is called magnitude. This length is called magnitude, and this is the direction. Okay, this is the magnitude. The length denotes the magnitude, and the arrow denotes the direction. So here this is the length. So a cos theta is the x component. Why a cos theta? You can use geometry to find the projection of this. Okay, so if this is theta, then it will be x cos theta, and this will be a y component. So this will be a sin theta. Okay, if this is ay, this will also be ay, and if this is ax, this will also be ax. Just for your reference. Okay. Now remember that component which is adjacent is cos component, which is perpendicular is sine component, always. Now if instead of this, if this angle was given, suppose this angle was given as phi, so ay will be a cos phi, okay, and ax will be a sine phi. Okay, so does not matter which angle x, it will not necessarily only the angle with x axis will be given, but remember the component which is next to the angle will always be cos component, which is called adjacent component, and the component which is perpendicular to other component is called the perpendicular component. Adjacent component, perpendicular component. Okay, always remember that. Now let's move on. Dot product and cross product. So vector multiplication. Even though vector multiplication we deals with some other chapter, but because vector is introduced in this chapter, I like to complete entire vector in this chapter itself. So dot and cross product. So what is dot product? So when two vectors are given, okay, and you are multiplying them, the result turns out, the final result turns out to be a scalar. That is called a dot product or scalar product. Okay, based on different situation. While multiplying two vectors, we can get a scalar quantity, we can get a vector quantity as well. So if the final resultant is a scalar quantity, then it is called a dot product, and a dot b is given by ab cos theta. Obviously we know that, and a cross b is the cross product. It is given by ab sin theta n cap. N cap is a vector which is mutually perpendicular to both a vector and b vector. Now suppose this vector is a vector, this vector is b vector. Dot product is basically projection. Dot product is kind of projection. You are taking the projection of this vector on the other vector, or this vector on the other vector. Okay, you have done this in mathematics. Okay, physical explanation of dot product and cross product. Okay, projection is basically dot product. Now what about cross product? Cross product is slightly tricky. Here the important part is how to find the direction of the resultant. Direction of the resultant is important. Suppose this is A, this is B. You want to find the resultant direction of the A cross B. So how to do that? Is A cross B, is it equal to B cross A? No. Okay, A dot B equals to B dot A. Does not matter. Okay, because it's a projection and final result is scalar quantity. So in terms of dot product, it is commutative. So A dot B equals to B dot A, but A cross B is not equals to B cross A. Even though magnitudes are same, directions will be different. Now how to find the direction of two cross product? So first you point your fingers in the direction of the first vector. So A cross B, the order matters. First is A vector. So point your fingers in the direction of A vector. Curl your finger towards the second vector, then your thumb will give the direction of the resultant. Okay, so this is the result. So obviously it's out of the paper. So A cross B is out of the paper. Now if you do B cross A, so B is in this direction. Now if you do the B cross A, obviously it will be into the page of the paper. So A cross B is not equal to B cross A. In fact, A cross B equals to negative of B cross A. So A cross B is actually minus B cross A. Okay, vectors are same in magnitude but opposite in direction. Okay, remember that A cross B equals to minus B cross A. They are opposite in direction. So A cross B, B cross A are exactly opposite in direction. Now, in many cases, there might be cases where you have to find the direction of the two vectors when they are being cross product. So remember that, point your finger in one direction, curl the fingers in the second vector direction, then your thumb will give the direction of the cross product. Now, there are some applications for cross product and dot product. If two vectors are given to you and if they ask that show that these vectors are perpendicular or find what is the angle between the vectors, generally we use dot product. Okay, dot product is basically to show that these two vectors are perpendicular. Okay, if two vectors are perpendicular, their dot product is 0. Okay, also if you want to find the angle between two vectors, you generally use the dot product rule. Cross product is basically when two vectors are parallel. If the vectors are parallel, their cross product is 0. So they will give you some vectors in terms of fundamental vectors of x, y, I cap, j cap and k cap. So if you go back to our previous slide, so this position vectors generally in 3 dimension, okay, x, y and z, okay, x, y and z. Okay, so the unit vectors are basically projection of one unit vector on x-axis. It is written by I cap. For y-axis it is written by j cap, and for z-axis it is written by k cap. In 3 dimension, I cap, j cap, k cap are called 3 unit vectors. Okay, these unit vectors can be used to represent any vectors. Any vector, for example, if I say a vector equals to 2 I cap minus 3 j cap plus 5 k cap. That means you go 2 units in the x direction, minus 3 means in the negative y direction you go 3 units, and then positive x direction you go 5 units, then you will get this vector. Units means 1. Okay, obviously 1 is generally defined. If you have drawn the graph in your class 10th graph equations in mathematics, there you have to define 1 unit. One smallest square in the graph paper is considered as 1 small unit. Okay, based on you have done graphing in your experiment also. There also you have defined what is the 1 unit means, right? So see, this 1 unit will be obviously known, and then you can define any vector using resolution of vectors. Okay, so basically if you given this vector, suppose this is vector A. Okay, if you resolve this vector into x, y, z component, you will get this vector. Okay, this is how you basically, this is the application of resolution. Okay, so when two vectors will be given to you and say that these two vectors are perpendicular, find the unknown value. Suppose one vector is given, a vector equals to say a I cap plus 2 j cap, and b vector equals to say 3 I cap minus 4 k cap. Now it says that a and b are perpendicular. What is the value of a? So in that case, what you have to do? You have to do a dot b equals to 0. Okay, a dot b has to be 0 because they are perpendicular. If two vectors are perpendicular, their dot product is always 0. Now remember that I dot I equals to j dot j equals to k dot k equals to 1, and any other mix is 0. Any other mix, I dot j, I dot k or j dot k, they are 0. Okay, so only when you are multiplying same vectors, same unit vectors, the value is 1, otherwise all mixed product is 0. So that means when you are doing dot product of a dot b, what you get? You can dot product only these two quantities. So 3 into a, 3a. Okay, these cross terms will be 0. Okay, so this cross term will be 0. Okay, so 3 into a minus jj, so it will be minus 8, and because the dot product is 0 on the right hand side, it will be 0. So from here you can say a equals to 8 by 3. So based on the question, they will give you such unknown cases, and if they say that okay, these two vectors are perpendicular, okay, what is the unknown value, then you just need to find the dot product, equate it to 0 and calculate it. Similarly, if vectors are parallel to each other, then you have to find the cross product. Now how to find cross product of two vectors? Okay, to find cross product of two vectors, you just need to just a second, let me add a page. Now to find the cross product, suppose we are doing A cross B, okay, and A is given by say AX I cap plus AY j cap plus AZ k cap. One of the component can be 0, okay, and suppose B vector is given by BX I cap, just a second, say BX I cap plus BY j cap plus BZ k cap. So how to find the cross product of A cross B? So in that case, you basically use determinant method, I cap, j cap, k cap, okay, AX, AY, AZ. Now you have used in mathematics, but you might be thinking, sir, that is a separate vector, maybe mathematical vectors are different from physics vectors. No, they are not. Obviously you can use this method, and same way you solve a determinant, you can simplify this determinant to calculate the cross product. Okay, now if it is a parallel vector, they will be 0, and from there you can say if x component is 0, y component will be 0, individually components will also be 0. One important thing is that in case of if when you calculate this vector, okay, individually all the components will be 0. So after calculating, I cap component will be 0, j cap component will be 0, k cap component will be 0. Okay, so remember that, right? Now let's move on to the next part where we are discussing vector addition. Now after multiplication we are coming back to addition. So when you add two vectors, say vector A and vector B, okay, they are making at some angle theta with them. How you can add these two vectors? So to add two vectors which are at an angle theta, the very simple formula is a square plus b square plus 2ab cos theta whole root. Okay, so this is the magnitude of the vector addition, magnitude of the vector addition. So this symbol obviously denotes the magnitude. So a plus b's magnitude is given by square root of a square plus b square plus 2ab cos theta. Sometimes this is represented as r. Okay, r is the resultant, or r square is equals to a square plus b square plus 2ab cos theta. Now in some cases, if theta equals to 90 degrees, just a special case, if theta equals to 90 degrees, then you can write this as r square equals to a square plus b square. Okay, obviously cos theta is 0. Simply you can write resultant is basically a square plus b square. So this is like a Pythagoras theorem. When two vectors are perpendicular, to calculate resultant you just need to use Pythagoras theorem. Okay. Now this is not over, you have to find the direction of this vector as well. Now if you are measuring the direction, angle alpha with respect to say vector A, you can find this angle with respect to B also. Okay, but if you are measuring the angle alpha with respect to vector A, then it will be b sin theta by b cos theta plus A. Remember this. Okay, so this is the angle with which you are measuring. So A is alone. So how to find the angle alpha? So tan alpha, which side, with respect to which side you are measuring the angle? With respect to A you are measuring. What is the sign? Tan. Tan means what? Tan means sin by cos. So sin by cos. Okay, so obviously it will be in terms of theta. Theta is known, given in the problem. So tan alpha equals to b sin theta by b cos theta, and whatever side you are choosing with respect to which you are measuring the angle, that will be alone A. Okay, just for your reference. Okay, the angle is not super important in KCET exam. Now, the one more important concept in this chapter is projectile motion. All the formulas are important, you have to memorize them. Okay, otherwise you will lose out on time, because if some question is coming, what is the time of flight, if you don't know the formula, you will lose out on time. Otherwise one question you have to miss. Okay, so if you are someone, except maybe equation of projectile, other formulas all are maximum height, range of projectile, time of flight, these three formulas are super duper important. Generally you might see one question based on this formula. Out of these three formula, one question will come, and obviously projectile, the equation graph of projectile looks like this. Okay, and what is the projectile motion? Projectile motion is in the absence of any other force, only in the presence of gravity. When the object moves, it is basically traces a parabolic motion, and that path is called projectile motion. Okay, remember that there is no other force except gravity, not even the drag forces. Okay, even if there is a drag force, it will not be exactly parabola. So the path is parabola only when only gravity is acting on it. Okay, other than that, it will be not a perfect parabola. So time of flight 2 v naught sin theta by 2. Obviously theta is the angle of projection with which the projectile is projected. That angle is given by theta. Okay, maximum height is v naught sin theta whole square by 2g, and range of projectile is v naught square sin 2 theta by g. Obviously the derivations are not required, only values and final answers are required. Okay, you have done the derivations in your P1. No, you do not need to do the derivation once more, just the formulas are sufficient. Range is maximum at theta equals to 45 degrees. Okay, so maximum range is when this projectile hits the maximum distance. Okay, so that is how a range of a projectile is determined. So if I say that BrahMos missile can hit a target at 100 kilometer distance, that means when it is launched at an angle of 45 degrees. Okay, so that's how we determine the range of a projectile. So range is maximum at an angle theta equals to 45 degrees. Now let's see one question, one type of question that is coming from this chapter, and then it will be we will conclude this session. A particle is projected with a velocity v so that it is horizontal range twice the greatest height attained. The horizontal range is, so particle is projected with a velocity v so that its horizontal range, okay, is twice the greatest height attained, and you have to find the horizontal range. You have to find the r. Now what is r? R is velocity, initial velocity is v, so v square sin 2 theta upon g. Okay, this is the range. As I mentioned, if you remember the formulas, it will be very, very helpful. Similarly, the height of the maximum height that projectile attains is given by v square sin square theta by 2g. Okay, v square sin square theta by 2g. Now we have to simplify. Obviously v square cancels. Okay, now we have to simplify. We basically we will just need to find this sin 2 theta value. Okay, if you can find sin 2 theta, that will be very easy, but obviously directly you cannot do that. G cancels, these two also cancel, so we get sin 2 theta equals to sin square theta. Okay, so if you can somehow find this value, it will be very, very helpful. Let's see that. So sin 2 theta means 2 sin theta cos theta equals to sin square theta. Okay, or obviously sin cancel, we get 2 cos theta equals to sin theta. Okay, and What is the horizontal range, by the way? Horizontal range, as I mentioned, is basically v square sine 2 theta upon g. Now if you can find the value of sine 2 theta using these equations, then only you can say, okay, what is the value? Obviously it is not 45 degrees, so you cannot say this is the maximum value, but how can we calculate sine 2 theta using this relation? Let's see what we can do. So sine 2 theta, 2 into sine theta cos theta. So obviously we can substitute, but here if you see the options, answer is independent of the theta. So we have to find and figure out the values of sine theta and cos theta. That is the major portion about this problem. Okay, now let's see. So from here we can find the tan theta. Obviously tan theta equals to 2. Sin theta by cos theta is tan theta. Now we are trying to find sine 2 theta. Forget about this. Okay, so sine 2 theta we are trying to find. Now we know that sine 2 theta obviously equals to 2 tan theta divided by 1 plus tan square theta. Right, this is an identity, so we will simply use that. So it will be 2 into 2 divided by 1 plus 4, right? Tan square theta means 2 square, so it will be 4 upon 5, right? So sine 2 theta is 4 upon 5, so we can write this will be 4 v square by 5 g. Okay, so some trigonometry, some physics combined together, basically we are solving it. So problem is simple, this much is physics, after from here onwards is basically trigonometry. Okay, sine 2 theta is equal to 2 sine theta by 1 plus tan square theta. So if you put that value, you will get the value of resultant. So the horizontal range is 4 upon 5 v square by g, right? So this is the end of today's lecture. Okay, and obviously one more formula is there, centripetal acceleration. Centripetal acceleration is basically when an object is moving in a circular orbit. Okay, there is always an acceleration which is acting in towards the center, which is called centripetal acceleration, and it is given by v square by r. So v is the velocity and r is the radius of the rotation. So this happens only in the rotational motion. So when an object is rotating in a circular motion, there will always be an acceleration towards the center of the circular path, and that acceleration is called centripetal acceleration. Its value is v square by r. In our upcoming chapter we will study about centripetal force and importance of it. Okay.